if there were only one type of charge in the universe, then so out of the given options we have to choose the correct one, and in all the options the left hand side is representing the amount of flux, that is the surface integral of electric field over the closed surface. Clear? Now he's saying that we have a one type of charge, means either we have a positive charge only or a negative charge only. Clear? Means we have only one type of charge. So let's consider that we have only a positive charge, let this charge is Q, and we have some surface, and due to this charge there will be flux, and the net flux that will pass through the surface is definitely zero, and this is happening when the charge is outside the surface. So the option B is correct, that when the charge is outside the surface, the flux associated with this closed surface is equal to 0. Now if you look at this first option, he is saying that the flux will never be equal to 0 on any surface, so both these statements are contradictory. So if this is true, so definitely this is a false statement, because here the flux corresponding to this surface has become 0. Now if we consider this statement C and D, so if you read this statement D, so here the flux that is equal to Q by epsilon naught if the charge or the charges of magnitude Q were inside the surface. So if this is a surface and this surface enclosing certain amount of charge, so the flux associated with this surface according to Gauss theorem is this, and hence this statement is also true. Clear? Because according to Gauss law we need only the net amount of charge that is enclosed inside the Gaussian surface. Clear? Means the sum total of charge. So when we have a particular type of charge, so this Q is representing that charge that is inside the Gaussian surface. Hence this fourth option is also right. And he is saying that this in option C, he is saying that E dot ds could not be defined. No, because the flux has nothing to do with the nature of charge. Clear? These are just the field lines that are passing through a given surface, so it is only associated with the amount of net electric field and the surface over which we are calculating the flux. So this option is wrong.